Hi everyone. Today we are going to study about indices. So what is an index notation? So when I talk about index notation, it looks something like this: a to the power n. So a is called the base and n is called the index. So it is also called the index. It is called the power and it is also called the exponent. Let's talk about the law of indices. Where do we apply the law of indices and what is the law of indices? You should know about it. Okay. So when I talk about law of indices, the first law of indices is if you have AB, the whole raised to n, the law says that it will be A raised to n and B raised to n. If you take it with an example, if your example is AB, the whole raised to 6, it means that A is raised to 6 and B is raised to 6. Your second law of indices would be if I have A raised to m multiplied by A raised to n, multiplication means addition. So it is equal to A raised to m plus n. If I take this as an example, I say I have 7 raised to 12 multiplied by 7 raised to 8. Multiplication means addition. So it will be 7 raised to 12 plus 8, which is equal to 7 raised to 20. My third law of indices would be if I have A raised to m divided by A raised to n. Always remember multiplication means addition. And division. When it is division, it means subtraction. So I have A raised to m divided by A raised to n. So it will be A raised to m minus n because it is division. Say for example, I have 8 raised to 7 divided by 8 raised to 5. So it will be 8. Division means subtraction. So it will be 8 raised to 7 minus 5, which would become 8 raised to 2. Here it is very important to note that the base should always be the same. The base should always be the same. Only then you can apply the law of indices. Okay. Raise to is always the power. Now we talk about the fourth law of indices. A fourth law of indices is A raised to m, the whole thing raised to n. So it will become A raised to m n. Let's take an example. I have 3 raised to 4, the whole raised to 8. So it becomes 3 raised to 4 into 8, which becomes 3 over 32. Base is 3. So how many laws have we done of indices up to now? We have done 4 laws of indices. What are the 4 laws of indices that we have done? The first one we did is I have AB raised to n. So it will be A raised to n, B raised to n. A raised to m multiplied by A raised to n. Base is the same. So it will be A raised to m plus n. A raised to m divided by A raised to n. Base is the same. So it will be A raised to m minus n. The fourth law of indices, A raised to m, the whole raised to n. So it becomes A raised to mn. Let's do the next law of indices, the fifth one. I have A raised to 1 upon m. So what is down? Whenever it is half, okay, 1 upon something, it will be converted into root. The first thing. Base would go over here. So it would be, the base would be A. 1 over m, 1 over anything is the root. So this would come over here and it would become m. Let's take it as an example over here. The example is I have 27 raised to 1 by 3. 27 is my base. So it will be root. The base would be inside the root and this 3 would come over here. So it would be cube root of 27, which would be 3. Let's take the next law of indices, the sixth one. I have A raised to m over n. So since it is upon, it becomes a root. The base would come inside the root A. The denominator would be over here. So it will become n and it will be A raised to m. Let's do it with one example. I have 8 raised to 4 over 3. So the base would come inside 8. The denominator would come over here 3. What is left is 4. So it would be cube root of 8 is to 4. So over here also the m would be over here. Okay. Now when I talk about cube root of 8 raised to 4, cube root of 8 is 2. The whole thing raised to 4. Cube root of 8 is 2. The whole thing raised to 4. 2 raised to 4 means 2 4 times. So this would become 16. Seventh law of indices. I have A raised to minus m. Anything which it is raised to minus, if I want to bring it to positive, I should put it on the opposite side. So it would be 1 upon A raised to m. Say for example, I have 6 raised to minus 2. So it will become 1 upon 6 raised to 2. 6 squared is 36. So it will become 1 over 36. Also, you should know that anything raised to 0, anything raised to 0 is always 1. Whenever I'm applying the law of indices, I should always remember that the base should be the same. This I should always remember that the base should be the same. So which things have the same base? I should know. Things that can be converted. Things that can be converted to the same base. So when I say that I have to convert it to the same base, so the first thing I should remember is that 4, 8, 16, 32, okay, or whatever, etc., can be written to the power 2. It can be written as powers of 2. Similarly, second thing, 9, 27, 81. That means this is 3 square, 3 cube, 3 is to 4. It can be written as powers of, it can be written as powers of 3. When I'm talking about this is 2 square, 2 cube, 2 to the power 4, 2 to the power 5. So you should know this. The third thing you should know, 16, 64, 256, etc., can be written as powers of 4. Okay. Similarly, the fourth one, 25, 125, 625, can be written as powers of 5. Let's take the first one and try to see some examples where we can do it. We can try to change the base. Please remember, you can apply laws of indices only when you have the same base. So you need to change the base. Say you have 8 raised to 4. You want to use the law of indices. Okay? So 8 is actually nothing but 2 to the power 3. So 8 is written as 2 to the power 3, the whole thing to the power 4. So this becomes 2 to the power 12. So I have changed the base to 2. Which law of indices I have used? I have used the law a raised to m, the whole raised to n, is equal to a raised to mn. Okay? Let's take another example. I have 8 to the power 4 multiplied by 32 to the power 2. Okay? Try to convert it. To apply the law of indices, I need to convert it to the same base. Use the law a raised to m multiplied by a raised to n, which will give you the base should be same. Multiplication means addition, so it will be a raised to m plus n. So when I am talking about 8, it is nothing but 2 to the power 3. I've not taken this 4 into consideration. When I'm talking about 32, it is 2 to the power 5. 2 to the power 5. The whole thing over 4 over 2. Okay. Now I have a raised to m multiplied by a raised to n. So what will this be equal to? This will become 2mn, 3 into 4 multiplied by 2 raised to 5 into 2. So this will become 2 to the power 12 multiplied by 2 to the power 10. So this becomes 2. A raised to m multiplied by a raised to n. It becomes a raised to m plus n. So 2 to the power 12 plus 10. So this becomes 2 to the power 22. The base should be the same to apply the law of indices. You can try these examples. The A1 base is the same, x to the power 2 multiplied by x to the power 5. Base is the same. Multiplication means addition, so it will be x to the power 2 plus 5. It will be x to the power 7. Let's take the next one. 2r square multiplied by 3r cube. Base should be the same. Base should be the same. Here the base is not the same. So what do? I split this up. I will say, I will rewrite the expressions with numbers together and r's together. So if I rewrite it with numbers together, so it will be 2 into 3 into r square into r cube. Check where the base is the same. The base is same here. So 2 into 3 would become 6 into r. Base is same. Multiplication means addition. 2 plus 3. So it will become 6r raised to 5. Okay. Let's take the next example. The C1. B over 7 divided by b raised to 4. Check. Is the base same? Yes. Division means subtraction, so it will be b raised to 7 minus 4. So it will become b raised to 3. Okay. Let's take the fourth example, the D1. Let's try the fourth example. Is the base same? No. So I have 6x5 divided by 3x3. Since the base is not the same, I will rewrite the expressions where I will split the numbers and I will split the x. So it will be 6 upon 3 multiplied by x over 5 upon x over 3. So this becomes 3 ones are, 3 twos are, so 2. Base is the same. Division means subtraction. So it will become 5 minus 3. So it will become 2x square. Let's do the next example. This is law of indices that you should know. So the E1, I have a raised to 3 over 2 mn into 2a square. Is the base same? No. Since the base is not the same, I will rewrite this where I will split the numbers and I will split the letters. So this becomes AMN. So A 3 into 2 multiplied by 2A square. So this becomes A raised to 6 multiplied by 2A square. Now I'll split the numbers and I will split the letters, variables. So it will become 2 into a raised to 6 into a raised to 2. Base is the same. Multiplication means addition. So this becomes 2 into a raised to 6 plus 2. So this will become 2a raised to 8. Are you with me? Let's try the next one. Please try the next one. Base should be the same. Do I have the base as same? No. So my next focus would be to make the base same. So this would become 3x squared, the whole to the power 3 divided by x4. Now remember, this 3 belongs to this also, and this 3 belongs to this also. So this would become 3 cube multiplied by x square, the whole to the power 3 divided by x4. To apply the law of indices, I need the base to be the same. The base to be the same. So this would become 3 cube multiplied by x mn raised to 6 over x raised to 4. Split the numbers, split the variable since it is a multiplication sign. So it would be 3 cube multiplied by x over 6 upon x over 4. So this would be 3 cube. Base is the same. X raised to 6 minus 4. 3 cube is nothing but 27. This will be 27 x raised to 2. Please remember, to apply the law of indices, your base has to remain the same. To apply the law of indices, the base has to remain the same. We'll give you another example. You can try it yourself. Let me give you another example. 9 over 4. Change the base to 3. How will you do it? So this will be 9 can be written as 3 square to the power 4. 3, 2 into 4. So this can be written as 3 to the power 8. Take another example. 9 raised to 4 divided by 3 raised to 7. You have to solve this. You have to make the base same. So this will be 9 up to the power 4 divided by 3 to the power 7. 9 can be written as 3 square over 3, 7, and to the power 4 would go over here. So this would be 3 a raised to m into a raised to n, a raised to mn, 3 to the power 8 divided by 3 to the power 7. Base remains the same. So 3 to the power 8 minus 7. So this would become 3. I hope this is clear. Okay. Let's try another sum. I'm giving you another sum. Check out. You are being given that y is equal to 64 x cube, and they want you to express it in the form of ax raised to n. Okay, where where a and n are integers to be found. A part y is equal y raised to 2 by 3, and your b part is y 2 by 3 into y square. Please try to do it. Please remember that a and n are integers to be found out. You have to find out a and n. And they have given you that y is equal to 64x cubed. You have to express it in the form of ax raised to n. So your first part is, your a part we are solving, y raised to 2 by 3. You're just going to substitute in place of y. You will write 64x cubed, the whole thing raised to 2 by 3. Just remember that when you're putting the law of indices, you can do one by one. You cannot apply more than one law of indices at the same time. So what you will do, you will give this 2 by 3 here, and you will give this 2 by 3 to x. So it will be 64 raised to 2 by 3, and you would have x cubed raised to 2 by 3. Are you with me? Whenever anything is in the division form, it means root. Denominator would come over here. Base would be down, and this would be the whole square. Again, multiplied by a raised to mn. So it would be x raised to 3 multiplied by 2 by 3. This 3 and this 3 cancels. So it would remain x squared. So this would become cube root of 64, the whole square, into x squared. I have to express it in the form of ax raised to n. I have got the x raised to n. Now I need to simplify this. 64. That means cube root of 4 is 64. Okay. So cube root of 4 is 64. So this is 4 square into x square. 4 square is nothing but 16x square. So I have expressed it in the form of ax raised to n. So y raised to 2 by 3 is 16x square, where y was 64x cubed. Let's do the b part. Our b part is, I've been given y 2 by 3 into y square. And what is the value of y? Y is 64x cubed. I have to express it in the form of ax raised to n. Okay? Come on. You cannot apply more than one index law at a time. Try. Base is the same. What will you do? Will you apply multiplication mn, or will you first solve the first index law? So when I say y 2 by 3 into y square, first I would substitute in place of y 64x cubed. Then I will write 2 by 3. in place of y 64x cube. Then I will write 2 by 3. Now think what will I do? 64x cube and then 2 by 3. I want you to think. Since this is the B part, you can also see we had found out y raised to 2 by 3 is nothing but 16x square. So instead of this y raised to 2 by 3, I can write 16x square. And over here, in place of y, I'm going to write 64x cube. Okay, 64x cube multiplied by raised to the power 2. Now let's see. 16x square multiplied by 64 square, and this 2 would go to x also. So it would be x cube, the whole raised to the power 2. So this would become 16x square. 64 to the power 2 becomes 4096. A raised to mn, this would become x raised to 6. Okay. Now we have to express it in the form of ax raised to n. So what do? We don't have the base same. So what do? We keep the numbers separate and we keep the uh, variable separate. So it would be 16 into 4096 into x square into x6. 16 into 4096, use your calculator. It will give you 65,536. And for this, a raised to m into a raised to n. Multiplication add, so it would be x to the power 2 plus 6. So this becomes 65,536 multiplied by x to the power 8. I want it in the form of ax raised to n. So it will become 65,536 x to the power 8.